Hello guys, welcome this morning. We will be getting started very shortly. Let me just bring up the Kahoot and get going with the code. I know there is, I've had a couple emails through this morning of people who can't find the link, so I will just share that with them. But today's code is there, so you can get going with putting in your stuff. Right, just give you 5 minutes on that timer to complete your entries, and then I'll be back and we'll get going. Okay, so yeah, about 30 seconds left for people to sign in to get going, and then we will yeah, like I said, get going with today's Kahoot. Some interesting questions in today's. Alright, so we will make a start then. Alright, so we've got 15 people playing today, so we will make a start. Let's get rid of the text. We don't need the text anymore. Okay, so this question then. Why do we use... Oh, I didn't change the order of these, but yeah. Why do we use resistors in combinations? This is all about combinations of resistors. Why do we bother? Now, yeah, select all that apply here. So we are looking at resistor combinations. I forgot I changed the order. This was meant to be later, but it will do here now. Okay, so yeah, 3 answers were correct there. So we use resistors because they only come in set values. They don't come in every value, and you might need a specific resistance. If we have them in parallel, each branch has less current going through it, so we can use thinner wire, can use less powerful resistors, which comes into this. They have a maximum temperature. So those we might have used this in school. If we use the wrong ones, they have a habit of burning up, so we have to be careful with the ones. So what's that done to our scores? So well done to Reese, well done to Hello, well done to ... well done to Hannah, well done to Annie. Our top 5 to begin with. All right, so some nice easy questions to keep us going. So what is this symbol that as it appears? Okay, yep, well done to 4 people who got that right. That is a thermistor. Excellent. So let's see what that's done to our scores. Well done, 200 IQ. You're the highest climber, up 5 places. Well done, Reese. Well done, Josh P. Now in 2nd place. Okay, right. So this open-ended. This is where you've got to type in an answer. All right, what does the D in LDR stand for? So type your answer in. unmic myself. Well done to the 7 people who got that right. Dependent, light dependent, resistor. Look at all those E's. That's why this is in here. Because the number of people who make that a dependent resistor, but no, it's dependent. Loads of E's, no A's. What's that done to our scores? Well done, LEJ, up 4 places as our highest climber here. Well done, Josh P, now top of the pile. Well done, ... Well done, Big Brain Time, up into the top 5. Okay, right, question 4. Let's just shut this door behind me. Put these SI prefixes in order of size. Remember, these are the things that go in front of our units. So, put them in size from the smallest to the biggest. All right, off you go. Okay, so well done to the 40% people who got that right. Yeah, it goes micro, which is times 10 to the minus 6, milli times 10 to the minus 3, kilo times 10 to 3, giga times 10 to the 9. So in terms of our scores, Parry, highest climber, up 4 places. Josh P still top of the pile. Hello now in second, and Big Brain Time in third. All right, excellent. Right, question 5. We have 3 1.5 volt cells connected in series. What voltage will they put out? Okay, well done. So 7 people got that right. Yeah, 3 in series. Add them up. 4.5 volts. So Will Smiley Face is our highest climber, up 4 places, but the top 5 haven't changed. Well done, Josh P. Top of the pile still. Right, question 6 of 21. In the diagram below, which way will the current flow through the diode? Here's our diode. Which way will the current flow through it? Okay, well done, 9 people. Yeah, it will flow left to right, so the current comes out the positive, the long side of a cell, goes all the way round, and the arrow points which way the current's going. All right, so in terms of our list, so Eliza Smith up 3 places, Big Brain Time is now into second, Reese in third, ... in fourth. But yeah, Josh P still top of the pile. Right, question 7. Which of these is a correct form of Ohm's law? So which one of these equations has been correctly rearranged? Okay, yeah, well done to, let's just move that camera back on me. Well done to 9 people who got that right. Yeah, V equals IR is the correct form of Ohm's law on there. Josh P has a streak of 7 answers correct now. That's excellent. And 200 IQ is now 3rd. Well done. Okay, so another quiz question, another multi-select. All right, so using Ohm's law, what current is flowing through a 240 ohm resistor if the voltage across it is 12 volts? Okay, so well done to the people who got this right. Yeah, the first 2, these are the same value, 0.05 amp and 50 milliamps, exactly the same value. So well done to 200 IQ, going up into 2nd place, now with their streak, up into 3rd, and Parry up into the top 5. Okay, so another quiz question, 9 out of 21, again multi-select, so there's more than one right answer here. A bulb has a voltage of 6 volts and a current of 0.03 amps. What is its resistance? There's not more than one right answer. Go back on. So problem with that question. Oh well done to the one person who got it right. Yeah, 200 ohms. Because what you would do is you do the voltage divided by the current and you get 200. I forgot to change that one. Well done to 200 IQ for getting it right really quickly. Alright, question 10 of 21. A 1 amp fuse protects a 9 volt power supply. What is the minimum resistance needed in this attached circuit? So what resistance do I need here so that fuse doesn't blow? Yeah, well done. That would be 9 ohms. Well done to the 10 people who got that right. So what's that done to our top? Yeah, 200 IQ, highest answer streak is 7. Well done, top of the pile. All right, question 11. In the circuit below, what is the value of the resistor? So in this circuit, what is the value of this resistor? Okay, well done to 6 people who got that right. Yeah, 300 ohms. you do again 24 divided by 8. Well, it's not 80, it's 0.08 because it's 80 milliamps and you need to work in amps. Well done to those 6 people who got that right. What's that done? Kenzie Nelson up 3 places, our highest climber, but the top 5 haven't changed, although the gap at the top's narrowed slightly. Right, in this circuit, what value resistor could you replace the 2 resistors with? So I've got 2 resistors here. How could I combine them? Okay, so yeah, well done. 10 people got that right. 2 resistors in series. You're just going to add them up, and you get 220. Right. Not changed our top 5, but all looking really good there. Right. Question 13. What value could these resistors be replaced with? All right. So we've got 2 now. What value could replace these? Okay, yeah, only one person got that right, 70.6. These 2 are in parallel with each other, so we don't add them up this time. We remember we do that funny add the reciprocal, so you do 1 over 100 plus 1 over 240. Then you take the reciprocal of that. By reciprocal, I mean 1 over, and what you get. So in terms of what you should have done in your calculator, if you've got a calculator to hand, here's calculator. You should have done 1 over 220 plus 240. Let's use the right numbers. Plus 1 over 100. And then you find the reciprocal of that, pressing this button here. And you get an answer of 70.588888888. So when you do that, it's not 70.5, doesn't round to that, it rounds to 70.6 out of those. So unlucky, this one person. Okay, so nobody on the top 5 got that right. Okay, so moving on. Which of the following resistor combinations would be the same as in the diagram? So this is what I've got in my diagram. Which of these combinations give me that resistance? Okay, well done to the 8 people who got that right. So yeah, this one would have given us resistance of 130, no good. This gives us a resistance of 177. This one, I can't remember what it does off the top of my head, but yeah, this one is pretty damn close to the right answer, so that would do. Excellent. Okay, so well done, ... who's now in second place. Jamie Morris, our highest climber, up 3 places. Right, so some information for you. Now, this is the resistor code. And you will have noticed on some of the pictures of resistors that we've been using, they have got coloured bands on them. And what do those coloured bands mean? Well, that's what we've got just down here somewhere, down there. We have got what the different colours mean. So the next 2 or 3 questions, I think it is, all need this table. Now, this table does come up again. But the way it works is you hold your resistor, and there will be either a gold or silver band normally on one side, so you put that as you're looking at it on the right hand side, and then the colours going across. The first 2 bands, they give us, because we're only going to use 4 bands, so the first 2 bands give us the value. So in this case it's green 5, blue 6, so 56. The yellow then gives us the multiplier, so it's 56 times 10,000, so it's 560,000. Okay, so good luck with these questions then. So use the code to select which resistor is a 100 ohm resistor. So each of these pictures, one of these is a 100 ohm resistor. So using this code to select which of these resistors is a 100 ohm resistor. Alright, well done, 3 people. Yeah, that's our 100 ohm resistor, because you go brown 1, black 0, and then it's brown again. So 1, 0, so 10 times by 10, 100 ohms. Okay, so what's that done to our scoreboard? Well done, 200 IQ, the only one on the top 5 to get that right. Excellent. Alright, puzzle then for you. So double points on this puzzle, because we're getting into our last 4 questions. Put these colours in order for a 470 ohm resistor. So if we had a 470 ohm resistor, what order would the colours be in? Okay, so well done to the, probably that's one person who got that right. The colours are going to go yellow 4, violet or purple 7, and then our third band is brown, so 47 times by 10, 470, and then gold goes on the end because that's our multiplier. Yeah, well done to 200 IQ, 3 in a run, top of the pile now. So again, this is multi-select, select the right answers, and worth double points. So what is the value of the bottom resistor? So what is the value of this resistor? Okay, yeah, so well done to those people who got those two right. So 1.8 and 1800. So yeah, so it's brown giving 1, silver or grey, sorry, grey giving 8, red 2, so 8 times by 100, or 18, sorry, times by 100, 1800 or 1.8 kilo ohms. All right, well done, Eliza Smith, up 4 places. Well done, Kenzie Nelson, back into the top 5. Okay, so again, still double points. Look at the circuit below. Calculate the current through the ammeter. So, calculate the current through this ammeter. Well done to 3 people, yeah, 0.08. So, how do we work this out? Well, we got 2 in parallel. So 1 over 100 plus 1 over 100 is 2 over 100. We then invert that and we get that this is then 50 ohms plus the 100 it's in series with. So the total resistance is 150. 12 divided by 150 is 0.08. So, well done to 200 IQ. Well done to Kenzie Nelson. Right. 20 out of 21. Again, double points. So, look at the circuit below. Calculate the current flowing through the battery. Don't know why this is double multi-select. There is only one right answer there. Yeah, well done to the 3 people who got 4 volts. I realised that when I went through the last question, I didn't actually have my microphone turned on. So, 12 volts. So, these 2 then are going to split the voltage in ratio of their resistance. So this gets twice as much voltage as this one. So it splits 2 to 1. So 12 split into 3 parts. Each part is worth 4. So 1 part, 4 volts. Or if you've got the previous question right, you do 120 times by that answer and you'd get the voltage across it. So in terms of our scores, okay, well done. In 3rd place with 12 out of 21, Josh P. It started off so promising and then tailed away. In 2nd place, ... with 13 out of 21 and with an amazing 19 out of 21, 200 IQ. Well done, 200 IQ, with runners up in 4th and 5th, Kenzie, Nelson and Parry. Alright guys, so if you've got any feedback, yes, you can fill that out. Let's go to just camera on here because we don't need to look at the screen anymore. So, well done guys. Hopefully you are all staying safe and you enjoyed that. Probably what I'm going to do next Tuesday in terms of the year 10, in terms of the circuit stuff, is going to do a little bit of the workbook first. So a little bit of this workbook, going through resistance on this workbook before I come back with some more questions, which I think in fact finishes this workbook. So this is available on the GCSE Physics workbook, GCSE Physics SharePoint page under electrical circuits, called Complete Workbook. If there are people who are interested in, and then after I've done that, we will do a Kahoot again. If there's people interested in just the Kahoot, what I will do, if you drop me an email and just say that I'm interested in just the Kahoot, I will email through when we're going to start the Kahoot and give people time to log into that. But yeah, going to go through this first, then go on to the Kahoot stuff, do another Kahoot after that. So yeah, Thursday 11 AM I'm continuing again. We are going to do some questions on magnetic fields and electromagnetism. So those guys in year 10 are watching this, those guys in year 12 watching this, worthwhile for both of you doing it. Because although, yes, it's year 10 material, and I've had a few questions from year 10 about whether is it worth doing stuff on this because it's the year 10 module. Well, we don't know what's going to happen with your year 11 exam. They may well put some year 10 work in it because you've not been examined on that. They might, depending on how long this situation goes on for, it might just be a year 10 exam that we do. I don't know. I know there is some more information that's due to come out today. So, yeah, final things then. Thanks for watching. Oh, sorry, I meant to say about year 12. Year 12, there is the same magnetic stuff is in year 13, is in unit 4 of year 13. So it's definitely worthwhile you guys doing it as a bit of a recap of what you've done a few years ago. So, final things then that I want to say is keep being safe, keep following the guidelines in terms of social distancing, making sure that, you know, we're staying in place, that you're staying at home as much as possible. You're only going out for your 1 hour's worth of exercise a day. And hopefully we will be in school before too long. Alright, so like I said, thanks for watching guys, and I will see you again Thursday.